Hey, welcome to this lesson video. We're going to be graphing exponential functions. So first, let's just real quick notice a few things. This is just a basic exponential graph. Notice it's just some number to the power of x. That's how we know it's an exponential function. The variable is the exponent. In this graph, we would call the parent function. There's no any transformations, no shifts, nothing exciting happening. Okay? If I look at this graph, and compare it to the first, you notice we reflected across the y-axis. And what caused that was negating the exponent, okay, or the x numbers. This graph compared to the first, we reflected across the y-axis this time. Okay, and what caused this to happen? Well, we negated the y value. So obviously, instead of being positive, they would shift down to negatives. Okay. In this graph, it's a little hard to tell what happened, but in the first graph, I'll click to it real quick. You see this point? It's at 0, 1. But in this graph, it's like this point shifted over 2 spots. And if you look at this exact equation, we had this plus 2. So when you add or subtract something to the exponent, what that does is it shifts your graph left or right, depending on whether you added or subtracted. And this direction, it actually is opposite of what you would think. The plus 2 made it shift to the left. Okay, this last graph where we've got our number raised to a power, and then we add some number to it, causes, if you can tell by the graph, a shift up or down. So in this equation, you notice we added 2, so the graph shifted up 2. Okay, so let's actually get to some graphing. So we're going to start simple, 4 to the x, and we're actually going to make a t-table, okay? But don't check out on me, it's going to be a little harder than you might expect, okay? Now we could randomly pick x numbers, and you could get some crazy big numbers or some crazy small decimals. I'm going to suggest be a little systematic, okay? And you'll save yourself a lot of time and energy. And here's what my system I would suggest to do. In the middle of the road, 5 points will suffice if you go my way. In the middle of the road, I would like to find 4 to the 0 power. So what did I replace x with to make it turn to a 0? Well, obviously I just replaced it with a 0. So when I plug in 0, I end up with 4 to the 0 for y, which is what I'm looking for, okay? I guess technically I should have y equals here since it's a function. Okay, once you find this middle of the road point, plug in x's 2 above and 2 below, and you'll get 5 nice points that you'll be able to see this like L-shaped curve, and you'll be good to go. So when I plug in a 1 for x, I get 4 to the first for y. When I plug in 2, I get 4 squared. When I plug in negative 1, I get 4 to the negative 1. When I plug in negative 2, 4 to the negative 2. So then just evaluate these numbers, and then we'll have our ordered pairs. So 4 squared is 16. 4 to the first is 4. 4 to the 0, anything to the 0 power is 1. Negative exponents do not make negative numbers, they make fractions, okay? So these next two, I know this much. Numerators are 1. 4 to the first power, it'll be a 4 on the bottom here. 4 to the second is 16, it'll be a 16 there, okay? So these are gonna be decimals, okay? We're gonna approximate where we put those points. It'll be okay. So let's graph these ordered pairs and see what happens. 2, 16. So when x is 2, we go up to 16. 2, 4, 6, 8, 10, 12. Well, I'm going to have to guess it's about up here somewhere. Okay. The point 1, 4. 0, 1. Negative 1 and a quarter. Negative 1, comma 1/4. So roughly almost to the axis. Negative 2, 1/16. I'm even closer to the axis. So you can see this curve happening. Oh goodness, that's not very good. This is going to be hard. Let's see. Ugh. Okay. So you can tell by your table of values or even by the graph, we're getting closer and closer to 0. So on assignments, I'll ask you for like the asymptote equation. So first, notice what the asymptote is. This green dashed line, we're getting closer and closer to that axis. As a side note, think back Algebra 1. X equals equations are vertical lines. Y equal equations are horizontal lines. So since my dashed line is going horizontal, this asymptote equation is y equals 0. I'll also ask you for the domain and range. This guy's domain, from left, I don't know where he starts, and technically to the right, I don't know where he ends. So his domain is negative infinity, positive infinity. His range, what appears to be the lowest point coming up from the negative numbers, it appears to be 0. But we know that's the asymptote and we never quite get there. So do I want parentheses 0 or bracket 0? Well, parentheses, since I never quite get to the value of 0. But then do I know his max value? I don't. So there's his range, 0 to infinity. Okay. Let's try another one. I'm gonna jump to example C. And again, it's understood there's this y equals because it's a function. So we're gonna make a t-table. Let's leave room for 5 points. And here's what I'd like. Middle of the road, I'd like y to be evaluated for 4 to the 0 power. So notice what's different here. We're negating the x numbers we plug in. So what number could I plug in for x, and it would make this negative x turn to 0? Well, plugging in a 0. Negative of 0 is still just 0. Negative 0 really doesn't exist. Okay, 0 is 0. So let me go 2 up and 2 down. Now don't make the assumption that the x's are always these 5 numbers. We'll see some examples where there's a shift happening. Okay. When I plug in a 2 for x, I end up with 4 to the negative 2 because I'm taking the opposite of the x numbers I plug in. 4 to the negative 1. When I plug in a negative number, it turns positive. So 4 to the first, 4 to the second. We already evaluated these in that last table, just different direction. This would be 1/16, 1/4, 1, 4, and 16. So when I plot these values, let's see what happens. When x is 2, I'm really close to the axis. When x is 1, I'm close, but not as close. When x is 0, I'm at 1. When x is negative 1, I'm up to 4. 1, 2, 3, 4. And when I'm at negative 2, I'm up at 16, where it's going to be off the graph a little bit. So let me see if I can do this. Oh, this is harder than it looks. And that's not a very good line. It's not supposed to touch there. So, again, you can tell by our tables, we were getting 1/4, 1/16. We're getting closer and closer to 0 as we move down the x-axis. So again, let me highlight the asymptote, even though my red line wasn't the greatest. Okay, we don't ever touch that green line. We're not supposed to. So that means the asymptote is the same, y equals 0. The domain here is the same, negative infinity to positive infinity. And actually the range is the same. We're still approaching 0. It's just instead of coming up to it, we're going down to it. But it's still a 0 with parentheses because we never quite get there. Okay, let's see. Maybe one more example for this video to get the hang of it. Let's do this guy. I'm jumping to example G. Let me make my table. X, Y. So, middle of the road, here's what I would like to find. Again, y equals this. I'd like y to equal the negative of 3 to the 0 power. So what did I plug into x minus 2 that made that turn into a 0? Well, if x were a 2, 2 minus 2 would be 0. Okay, so here's where we're going to see a shift in our numbers. I'm going to go 2 up and 2 down, and let's see what happens. When I plug in 4 minus 2, I'm going to end up with a power of 2. When I plug in 3 minus 2, I'm going to end up with a power of 1. Already got that one. When I plug in a 1 minus 2, I'm going to end up with a power of negative 1. And when I plug in 0 minus 2, I'm going to end up with a power of negative 2. Okay, so be careful with your calculator. There are no parentheses. So we're not doing negative 3 squared. We're doing 3 squared and taking the negative of that. So negative 9, negative 3, negative 1. Now remember, 3 to the negative 1 is a fraction, 1/3, but that negative sign hanging out front will make it negative. 3 to the negative 2 makes the fraction 1/9. The negative out front makes it a negative fraction. Okay? So let me pull out these. 4, negative 9. 3, negative 3. 2, negative 1. 1, negative 1/3, so I'm almost to the axis. 0, negative 1/9, I'm even closer to the axis. So hopefully you can see we're getting closer and closer to this 0 again. Okay, so I'll come up to it. Hey, it was pretty good up to the end. It's supposed to still keep increasing, but oh well. Well, no, I'll fix that. That's kind of annoying. Well, not much better. Okay, we're just gonna call it at that. So since I'm going through 0, my asymptote equation is y equals 0. And my domain and range, negative infinity, positive infinity. This will be the same for all the exponentials. The range is what we have to be careful with. This time, do I know his lowest point? I don't, since this is shooting down. What appears to be the highest point is 0, but we know we never quite get there, so put a parenthesis. Okay. Actually, I said I was only going to do one more, but I think now I'm going to do one more. This will be a good one, where we see a shift up or down. So I'll buzz through this one a little quicker. Okay, so 1, 2, 3, 4, 5. Better to have too many examples than not enough. Okay, so here's what I would like. 3 to the 0 power minus 4. So what do I plug in for x? That makes that turn to a 0. So go 2 up and 2 down. So here's what I end up with. 3 squared minus 4, 3 to the first minus 4, 3 to the negative 1 minus 4, 3 to the negative 2 minus 4. Okay, and then when I figure out these values, 3 squared, 9 minus 4 would be 5, 3 minus 4, negative 1, 1 minus 4, negative 3, 1/3 minus 4. If you're not good with fractions, you might want to plug that in your calculator. Negative 3 and 2/3. And then this next one, 1/9 minus 4, negative 3 and 8/9. So if you look at our table, we're getting closer and closer to negative 4. So that's probably where we're going to have an asymptote. So let's see. 2, 5, 1, negative 1, 0, negative 3, negative 1, almost negative 4, negative 2, even closer to negative 4. So yep, you can see we're approaching this value of negative 4, so that's my asymptote. So here the asymptote equation changes, y equals negative 4, and then we're going to connect this graph. Okay, I don't have time for domain and range, but I'll see you next time. Keep learning and have fun.